In this session, we are going to find the pressures by ions and electrons. So pressure is equal to the momentum transferred per unit time per unit area from gas to the wall. So when the particle is moving to this direction with the momentum of the p sub x, then if we only consider elastic collisions, the particles after the collisions has a momentum for the p sub x. So change of the momentums delta p sub x is equal to the actually 2p sub x. So each single collisions of a particle with a wall, change of the momentums is expressed as 2 times px. This is the momentum change per each particles. Then we'd like to find out how many collisions are happening between the wall and the particles. This is the p sub x is the momentum of the particles. Then when you want to find out the velocities, velocity is given by the p sub x over m. M is the mass of the particles. We'd like to consider the cylinders. The area of the bottom of the cylinder is given by the capital A. Then if you consider the height of the cylinder is a v sub x times the delta t, then all the particles inside of these cylinders can collide with these regions of our walls because the particle is moving to this direction with the same velocities. We just only consider the single velocities of the particles, but x component is expressed as v sub x. Then if you take a height of the v sub x and delta t, if the particle is located close to the wall, it takes a shorter time to actually strike the walls. Even if the particle is just at contact with this bottoms of the cylinders, it can actually strike the walls after the time of the delta t. All the particles inside of this cylinder actually hit the walls. Then we'd like to find out how many particles actually exist there. At first, we need to calculate the volume of these cylinders. Volume is expressed A is areas times height is a v sub x times delta t. Then you can calculate this is the volume. A times v sub x times delta t is a volume. Volume times number density. So n is a number density. If you multiply the n, this becomes the number of the particles exist inside of these cylinders. But in this case, is all the particles moving to this direction. But if all the particles start moving to this direction, we expect vacuum is going to be formed in these regions. But it's not happens. Actually, this view is incorrect. Actually, half of the particles have to move to the opposite direction. Then there is no vacuum is forming inside of our cylinders. So we have to multiply 1 over 2 to take into account half of particles move in the positive x directions while the other half move in the negative x directions. Then this 2 is going to be cancelled out. So the momentum transferred across the area A during the time of the delta t is expressed L times A times v sub x p sub x times delta t. Okay, so momentum transferred across the area of A during the time of the delta t is expressed n times A v sub x p sub x. So pressure is a force per unit areas. We have to divide it by A. So this is going to be cancelled. Then to find out the unit times, you have to divide it by delta t. So it becomes n v sub x p sub x. we only consider all the particles have the same magnitude of the velocities, same speed. But actually the sum of the particles moving the very fast, some other particles moving very slowly. So we have to take into account such a distribution of the velocities. So actually the pressures we expect can be calculated. N v sub x p sub x. If all the particles have the same velocity, but we have to take into account the distribution of the velocities. So it's expressed with a blanket. Blanket indicates the average value over all the particles. Then, if we consider the isotropic distribution of the particles, so there is no special direction. X direction, Y direction, and Z direction is all the same. So this means V sub x, P sub x, plus B sub y, P sub y, plus V sub z, P sub z. So this is equal to V sub x, P sub x, V sub x, P sub x. So actually this equals 3 V sub x, P sub x. Actually this is equal to the B and P. So from these equations, actually you could calculate V sub x, P sub x equal 1 over 3 Vp. So you can substitute this relation to the here to come to the next line. Then the average value is expressed using the integrals Vp, and then you have to multiply the distribution function, the Np dp. Okay, we have to perform this integral to consider velocity distribution of the particles. James Maxwell found out the probability of the gas molecules having the velocity following Gaussian distribution. So horizontal line is the velocity, and the vertical line is the probabilities. So particle exists in these regions. If you express the P sub x equal mv sub x, then you can express the exponential minus P sub x square over 2mkt. The distribution functions we discovered, if you integrate over such a distribution over the P sub x, P sub y, P sub z, so you need to multiply these functions. So as a proportional constant, we put a capital S. Okay, so if we integrate over the momentum space, P sub x, P sub y, P sub z, it becomes a number density. How many particles exist per unit volumes. So we'd like to perform these integrals. But in this case, the P sub x, P sub y, P sub z is a Cartesian coordinate. This is P sub x, P sub y, P sub z. We'd like to change the coordinate from the Cartesian to the spherical coordinate. In the spherical coordinate is the distance from the origin is expressed as p. And the angle between the p sub z axis to the p is a theta. The projections onto the p sub x, p sub y planes. This angle becomes a phi. So integral like a dpx, dpy, dpg means you can create some small box. This is a dp sub x, dp sub y, dp sub z. And you can integrate over the sum up these small box into the whole space. But in the case of the spherical coordinate, you have to create these kind of the small box. This is dp. Then you could consider that this circles. Then radius of the circle becomes p sine theta. Change of the d thetas. So this is d theta. Then this length, it becomes p times d theta. Would like to change the phi. So this point is correspond to d phi. Then this is on the circumference of a circle with a radius of p sine theta. So this angle is expressed d phi. So distance is expressed p sine theta d phi. So you can create box volumes of this box, small box. You can multiply this to find the volumes. Also in the case of the dp sub x, dp sub y, dp sub z, you multiply these three lengths. In the spherical coordinate, you can multiply it. So p sine theta d phi, p d theta times dp. So this equation is integral is expressed p squared sine theta dp d theta d phi. Okay, this is an integral over the spherical coordinate. Then we'd like to return to the equation. So this integrals, as I explained, this could be changed. P squared sine theta dp d theta d phi. So p squared dp sine theta d theta d phi. This is long d phi. Okay. Then last part, it becomes 2 pi. This part you can integrate, it becomes 2. So multiply this last part, it becomes 4 pi. And to perform this integrals, I have already shown you 0 to the infinities. X squared exponential minus alpha x squared dx. It becomes square root pi over 4, 1 over alpha, 3 over 2. I derived these formulas, and then you can apply this. Then you can perform these integrals. It becomes 1 over 4 pi times 2 pi mkt, and power index 3 over 2. So this is equal to the L. Then capital A is going to be expressed this equation. So distribution functions actually is expressed this forms.